All right. Today we are going to look at uh, the quotient rule of derivatives. So that is 2.4, section 2.4 in your textbook. So this is how the rule goes. Let's say you have h of x equals f of x over g of x. Then when you take the derivative, we don't do h prime divided by g prime, okay? Instead, we use this rule, okay? So h prime is derivative of f times g minus derivative of g times f over square of the denominator, okay? So if you cover this, the top one, the numerator, looks like the product rule. So for the product rule, remember, we just have this, we don't, instead of negative sign, we have a positive sign. So when we have a quotient rule, so that is a subtraction. And then, of course, we divide it with the square of the denominator. If we use the Leibniz notation, let's say we have a function u over v, and we want to take the derivative of that. So we take the derivative of u relative to x times v minus we take the derivative of v relative to x times u over v squared. Let's apply this rule. So we are given h of x for x cubed minus 2x squared over x squared plus 3. Yes, on the test, if I ask Leibniz notation, so it will be clear which notation to use. But at the end, you are taking the derivative the same way. All right. So let's take the derivative of h. Okay. So what do we do? So derivative of the numerator. So let's use actually different colors so that. So let's call this f and g. Then h prime would be f prime times g minus g prime times f over g squared. Okay, so without the x's, you can just simply represent it like this. So we are going to take the f prime, the derivative of numerator, which is 12x squared minus 4x. Okay, so that is f prime. So we multiply this by g x squared plus 3. So that is g minus g prime, which is the derivative of the denominator, to x. So that is g prime. So we multiply this by f for x cubed minus 2x squared. That is f over g squared. So x squared plus 3 squared. And that is your g squared. Now we need to simplify. Okay, so check if there is anything to be factored out. For now, if you factor x, then you will see that x is a common factor. But in this case, we don't see any brackets to be factored. So let's then expand those brackets and collect the like terms. So we have 12x to the power of 4 plus 12x squared minus 4x squared, no, x cubed. Here's my eraser. Minus 12x minus 8x to the power of 4 plus 4x cubed over x squared plus 3 squared. We have then 4x to the power of 4, 12. The x cubes are gone. And then we have, is there a mistake here? Let me see. Yeah, that's supposed to be 36, right? 36. There we go. X cubes are gone, so 36x squared, and we have minus 12x. X squared plus 3 squared. Now we see that 4x is a common factor in numerator. 4x, so we get x cubed plus 9x minus 3 over x squared plus 3 squared. So your final answer, everything must be in factored form. Okay. Okay, we have another example. H of x equals 5x to the power of 4 minus 3x squared minus 5 over negative 2x cubed. Again, we are looking for h prime. Okay. Let me use again the color pencils. So let's call this f. Let's call this g. So f prime times g, f prime. So we are taking the derivative of numerator, 20x cubed minus 6x times g, negative 2x cubed minus g prime, negative 6x squared times f, 5x to the power of 4 minus 3x squared minus 5 over g squared, negative 2x cubed squared. So again, this is f prime, f, this is g prime, and that one is g squared. So whenever there is a rational function, that's, that is the rule, the quotient rule you have to use. All right, so now again we have to simplify the numerator. So we get negative 40x to the power of 6 plus 12x to the power of 4 plus 30x to the power of 4 minus 18, and now that is 6. And this is 4, and negative, negative, negative. So negative 30x squared. And denominator is 4x to the power of 6. So collect the like terms. We have negative 10x to the power of 6 minus 6x to the power of 4 minus 30x squared over 4x to the power of 6. So looks like 2x squared is a common factor. I'm going to take negative 2x squared. So 5x to the power of 4 plus 3x squared plus 15. That's it, yeah. Okay, 4x to the power of 6. Now we can simplify these two. negative sign, leave. We have 5x to the power of 4 plus 3x squared plus 15 over, so 2x to the power of 4. If you got something that is factorable, so you have to continue factoring. But in this case, this is not, so we just leave it there. Last question. Determine the points on the graph of h of x equals negative 2x squared over 3x minus 1, where the slope of the tangent is negative 1 over 2. Okay, so we are going to find the points where the tangents have a slope of negative 1 over 2. So of course, to be able to solve that, we need to take the derivative and make it equal to this negative 1 over 2, right? So derivative of this function, again, is the formula for the slopes of all the tangents. So we need to make that formula, which is the derivative, equal to negative 1 over 2 to find the x values of those points. So example 3, h prime, derivative of numerator, negative 4x times denominator minus derivative of denominator 3 times the numerator negative 2x squared over square of the denominator. So let's simplify this. Negative 12x squared plus 4x plus 6x squared over 3x minus 1 square, negative 6x squared plus 4x over 3x minus 1 square. Even 2x is a common factor here, but now we are going to make it equal to negative 1 over 2 and solve. So that is the reason, I'm not factoring the 2x, but if we are only looking for the derivative, yes, you should be also factoring 2x. So that is a derivative function. So we want derivative or the slope to be negative 1 over 2. Okay, because see, the slope must be negative 1 over 2. So we made the derivative negative 1 over 2. Now we're going to do cross multiplication. Okay, so negative 3x minus 1 square equals negative 12x squared plus 8x. So now expand this square, 3x minus 1 square, so 9x squared minus 6x plus 1. Distribute the negative sign, negative 9x squared plus 6x minus 1, negative 12x squared plus 8x. Let's collect everything on one side. So we get 3x squared, move this, minus 2x minus 1. So let's factor it. Okay, so 1 and 1, so negative 2x, so this might be negative, positive. So we get 2x values, x being negative 1 over 3, and x equals 1. Now we are going to get the y coordinates of those points. So we're going to sub in the original function here. Okay, so h of negative 1 over 3 equals negative 2 times negative 1 over 3 square over 3 times negative 1 over 3 minus 1. Okay, So negative 2 times 1 over 9 over, so this gives you negative 2. So they are gone, 1 over 9. So 1 point is negative 1 over 3 and 1 over 9. So let's calculate the y coordinate for x equals 1. So negative 2 times 1 square over 3 times 1 minus 1. Negative 2 over 2 gives you negative 1. So other point is 1 and negative 1. So just to demonstrate what we calculated here, I have the drawing from before, so I'll show you that. Okay. So that is the function negative 2x squared over 3x minus 1. So we got the points, which is negative 1 over 3 and 1 over 9, and 1 and negative 1. And at those points, if the tangents are drawn, the slopes are negative 1 over 2.